today in this lesson is to learn how to remove the base of exponents in order to arrive at an isolated x. What am I talking about? Let's look at that. You're working a math problem and it has an x in the exponent position. What you would like to do is accomplish the removal of the 3 so that you have the x isolated by itself. This is a simple enough process. We've already looked at a lesson where we went into why this works. For now, we want to master making it work for you. Let's suppose you start with the following equation. The first rule, in order to apply what we've learned, is to isolate the term that you want to work with. In this case, 3 to the x. We've already learned how to do that. We subtract 5 from both sides. We think of it as moving the 5 to this side and subtracting it. So you have 3 to the x power equals 4. Now we would like to remove the 3. The process for that is extremely simple. You have an x on this side, and on the other side, you have a logarithm, base 3 of 4. There's nothing more to this process than just that. So what have we done? How do you remember this? How do you flow through this easily? What we've done is we've taken a base 3 of an exponent. We've moved it to the other side of the equation, the entire quantity, and I'll show that this way, and made the 3 into the base of a logarithm. 3 stays a base on both left and right sides of the equation. On one side is the base of a power, or exponent. On the other side is the base of a logarithm. Let's see that again. Suppose I have 4 to the y power minus 2 equals t. I want to isolate the y. In other words, I want to solve for the y. The process is, first isolate the term that you want to work with, the 4 to the y. Easy enough. I add t to 2, to both sides. Having done that, I remove the 4, being a base on the left, to being a base on the right. And I'm finished. I have solved for y. Now there are going to be situations in which you wish to take this answer, simplify it, modify it, do something to it to meet some other needs of yourself or your teacher, the situation. But nonetheless, this is the point to which you have solved for y. Anything that follows is simply some other process in mathematics. Let's look at another example. Ten to the z plus 2 equals 5. In this problem, the term I wish to work with is already isolated. I'm ready to begin. I remove the 10, and I'm left with z plus 2 on the left. On the right side, I have a logarithm base 10. This is the only case where you don't write log, L-O-G, with a base shown. If there is no base showing in the word log, it means base 10. Z plus 2 is equal to the logarithm, base 10, invisible 10, of 5. But I have not yet solved for z, and that was our goal. Subtract 2 from both sides. And we're finished. We have now solved for z. Let's do a couple of these together, and you should find a bunch of problems in a book with answers to test your ability to do this part of the problem. Practice problem number 1. 5 to the a plus 3 equals 17. The term I want to work with is already isolated, so I'm going to remove the base. On the other side, I have a log base 5, and I still have a 17. I'm almost finished. Remove the 3 from the left side by subtracting it from the right side. And you're finished. Practice problem 2. Minus 7 to the 2b. Now you have to decide if the minus sign is included with the exponent, with the base of the exponent, or not. The answer, no. So it's the 7 to the 2b power, it's the negative of that, added to 9 equals 1. I want to remove the 9. I subtract it from both sides. I want to remove the minus sign. I change the sign of both sides. Now I have the term isolated. I must remove any negative sign that precedes it. I remove the 7 by finding the log base 7 of the entire right side. I'm almost done. I need to remove the 2. Remove a multiplied 2 on one side by dividing everything else, in this case, this term here, by 2. And I'm finished. 2 more problems. 4 equals 17 to the y power minus 1. Doesn't matter what side the variable's on. All we want to do is isolate the term with the variable in it. Add 1, and we have 17 to the y power. Now we wish to remove the base, 17. It becomes a logarithm, base 17 of 5 equals y, and we have completed the work. One last example, number 4. I've tried to make this look ugly. A look ugly problem is one that stops you in your tracks. You don't want to let it do that to you. I call them LUPs, L-U-P, look ugly problems. This is one of them. Focus your attention on the variable that you want to solve for, the z. We want to isolate it. Fine, let's remove the subtract 1. Add 1 here. Focus your attention on the variable. We wish to remove the 2. We divide, and we have done so. Leave it as a mixed fraction. Now we wish to remove the base, base 5. We do so, we have c plus 3 equals logarithm, base 5 of 13 over 2. Now we want to remove the add 3. We do that by subtracting 3 from the other side. And we are finished. We have solved for z. Now your teacher will tell you that there are other things you can do with this form. It is not in calculator-ready form. It hasn't been simplified. All those are part of another lesson. This lesson was for how to remove the base of an exponent, and we've done so, and you will see that it's very simple to do this. So practice this procedure until you're comfortable with this, until you can flow through it. The idea is to be intuitive in doing this so you can focus your attention on other things that you need